Welcome to the unit on equations and inequalities, solving quadratic and linear inequalities. The objectives for this session are to solve quadratic and linear inequalities. So how do we solve a quadratic inequality? We first rearrange the inequality so that the right-hand side equals 0. Then solve to find the critical values, sketch, and then use the sketch to find the required values. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a. Find the set of values for which f of x equals x squared plus 2x minus 8 is greater than 0. Now if we factorize x squared plus 2x minus 8, we get x minus 2 times x plus 4. So the critical values are x equals 2 and x equals minus 4, because this is when the equation equals 0. So the critical values are as shown on your diagram. Notice that the shaded region is the bit we're actually required to find. This is where the function f of x is greater than 0. And the values of x which satisfy this are x less than minus 4 or x greater than 2, as shown. Now we have actually solved the question. However, just for completeness, we'll go through other key points as well. The shaded region as shown is where f of x is less than 0. And here's a summary of the key points. Now let's solve example 1b. We are required to find the set of values for which f of x equals minus x squared minus 4x plus 5 is greater than 0. If we factorize this equation, we get 1 minus x times x plus 5. So the critical values are x equals 1 and x equals minus 5. As shown on our graph. The shaded region is where x is greater than 1 or x is less than minus 5. This is where f of x is less than 0. However, this region is where f of x is greater than 0. In this region, x is between minus 5 and 1. And here is a summary of the key points. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Now let's solve example 2a. We are required to find the set of values for which x squared is less than 2x plus 15. In order to solve this, we need to rearrange this inequality so that the right-hand side equals 0. As shown. We've taken over 2x plus 15 to the other side. Now let's consider when x squared minus 2x minus 15 equals 0. Factorizing gives us x plus 3 times x minus 5 equals 0. And therefore, if this is true, then x equals minus 3 or x equals plus 5. Let's plot this on our graph. So let's take a look at what's happening. If x is less than minus 3, then x plus 3 is negative, and x minus 5 is also negative. we have that a negative times a negative is a positive. If x is between minus 3 and 5, then x plus 3 is positive, and x minus 5 is negative. And if we multiply x plus 3 by x minus 5, we're multiplying a positive value by a negative value to give a negative value. And finally, for x greater than 5. If x is greater than 5, x plus 3 is positive, x minus 5 is also positive, and therefore x plus 3 times x minus 5 is positive also, since a positive times a positive is a positive. So the values of x which satisfy x squared minus 2x minus 15 less than 0 are minus 3 is less than x is less than 5. Now let's take a look at example 2b. Using part A, we are required to find the set of values for which x squared is less than 2x plus 15 and 3 plus 4x is greater than minus 5. From part A, we already know that x squared is less than 2x plus 15 gives us minus 3 is less than x is less than 5. Now 3 plus 4x is greater than minus 5 implies x is greater than minus 2, simply by rearranging that equation. So the region where x is between minus 3 and 5 is as shown. And the region where x is greater than minus 2 is as shown. And we want both of these to be satisfied simultaneously. And the two sets overlap when x is between minus 2 and plus 5. So in set notation, this is the set of x such that minus 2 is less than x is less than 5. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to find the set of values for which 5 over x is greater than 3 and x is not equal to 0. Let's begin by multiplying by x squared. And that's specifically x squared, not x, because x could be negative, and that will be problematic in that we will have to turn the inequality the other way around if it is. And if it's not, then the other case will hold. So that's why it's easier simply to multiply by x squared rather than x. So multiplying by x squared gives us x squared times 5 over x is greater than 3 times x squared. And cancelling gives us that 5x is greater than 3x squared. And then rearranging so that we have a 0 on the right hand side gives us 5x minus 3x squared is greater than 0. And then factorising gives us x times 5 minus 3x is greater than 0. And therefore we have the critical values, which are x equals 0 and x equals 3 over 5. So let's plot these. Now the solution, or the region where 5 over x is greater than 3, is the region in between these two critical values, or the set of x values such that 0 is less than x is less than 3 over 5. So this brings us to the end of this session. If you have understood its contents, you should be able to solve quadratic and linear inequalities. Thank you very much for listening. If you would like to understand this topic in greater depth, do attempt the exercises related to it in your textbook.